In this video, we're going to be looking at how we can calculate a confidence interval. Now, if you haven't seen the video on normal distribution yet, please watch that first. Now, when we calculate a confidence interval from a sample, there are two things that we need to work out first. That is the mean of the sample and the standard error. The mean is calculated by adding the values together and dividing by how many there are. This is 449 over 3. Now, a sample mean deviates from the actual mean of a population. This deviation is the standard error of the mean. So the standard error is the standard deviation divided by the square root of how many values there are. This is 2.2 divided by the square root of 3. Now, with a standardized normal distribution, we know that the area underneath the curve always adds up to 1. And if I ignore the top 2.5% and the lowest 2.5%, that means that the middle is now my middle 95%. This would contain 95% of the data. So you'll notice that this point ignored the top 2.5%. This means the area under the curve up to this point would be 97.5% of the information. Our goal is to work out what the Z value is at this particular point. We can do this by using the inverse table so that we can work out that for a given probability, the Z would be less than x minus x bar all over the standard error. And this would be 0.975. So looking at my inverse table, probability is written down the left hand side and in bold going across. All the values in the table are my Z scores. I'm after 0.975. Well, here is 0.97 and 5 in the third decimal place. Reading down and reading across, we can see that the Z score is 1.96. If the value that we've calculated to the right of 0 is 1.96, that means to the left of it, because of symmetry, is minus 1.96. So this means that my Z value is plus or minus 1.96. So now that we know that Z has to be plus or minus 1.96, that means that x minus 449 over 3 divided by the standard error, which is 2.2 divided by the square root of 3, is equal to plus or minus 1.96. Multiplying both sides by 2.2 over root 3 gives me x minus 449 over 3 is equal to plus or minus 1.96 times by 2.2 over root 3. And finally, adding 449 over 3 to both sides, x will equal 449 over 3 plus or minus 1.96 times 2.2 over root 3. Grabbing a calculator and typing these in, x can now be 147.18 to 152.16. This is my confidence interval. Pause the video here and have a go at the question on the right hand side. When you're ready for the answer, press play. As we did before, we need to calculate the sample mean and the standard error. So x bar will equal 126 add 169 divided by 2, which is 147.5, and also the standard error, which is 1.6 divided by the square root of 2. In this case, I'm after a 94% confidence interval. So that means I need 3% off the top, 3% off the bottom, so I've got the middle 94%. This means I'm calculating the probability that z will be less than x minus 147.5 over 1.6 divided by the square root of 2, so that it's equal to 0.97. Using my inverse table, here is 0.97, here is the 0 in the third decimal place, so reading down and reading across, that means that z will be plus or minus 1.8808. So now we know that x minus 147.5 over 1.6 divided by the square root of 2 will now equal plus or minus 1.8808. Timesing both sides by 1.6 over root 2 and adding on 147.5 would give me x is equal to 147.5 plus or minus 1.8808 times by 1.6 over root 2. Grabbing a calculator and typing this in, x will have a confidence interval of 145.37 to 149.63.